ASP.NET Core MVC from the ground up, this course will take you there. We'll start by breaking down the entire MVC app structure, exploring every file, covering the main concepts you need to know, and then dive into working with databases using Entity Framework Core, from CRUD operations to complex database relationships. We will be using the latest .NET version, .NET 9, and it's going to be super simple. Well, welcome to Code the Future. My name is Alan, and I help you learn C# and .NET on your own. Now let's get into it. I'm going to explain to you what the MVC architecture is in programming, and I'm going to walk you through everything you need to know. MVC stands for Model View Controller, and it is an architectural pattern that divides an application into three primary components: models, views, and controllers. This separation helps achieve a clear division of concerns in our applications. Separating concerns or responsibilities in MVC makes the application easier to develop, debug, and test because each part, either the model, the view, or the controller, has a specific job. When responsibilities are mixed, like combining user interface and business logic, changes to one can affect the other, making updates and testing harder and more error-prone. For example, user interface logic changes often, so if it's combined with business logic, you'd need to modify and retest both every time the interface changes. Now let's see each of these components in more detail. The model in MVC represents the information or the data the application operates on and handles the logic for processing this data. For example, if you have an application for managing books in a library, the model would represent the data about the books and the rules for adding, updating, or removing books from the collection. A view in MVC is the part of the application that displays the data to the user. A controller then manages user input and interaction, determining which model types to work with and which view to render, effectively controlling the application's response to requests. I'm going to show you how to download and install .NET 9 and the latest version of Visual Studio, which is our IDE, in order to be able to work in .NET 9. So let's get into it. So I'm just going to click on Google, download .NET 9, and we'll see the first thing we have here in the Microsoft's website. We should be redirected to the page that allows us to install the .NET 9 SDK. In the time of recording this tutorial, we have the 5th preview of .NET 9. Probably when you will see this, it will be fully out, the final .NET 9 version, but this is what we'll use, and there shouldn't be many changes with the final version. So here we have .NET 9 preview 5. Depending on your operating system, here just choose the correct one for you. I am using Windows and my processor is a 64 processor. I'll select this option right here and we'll wait for .NET 9 SDK to be installed. So it is already installed. Let me click on it. Click on install here. Okay, the installation was successful. Let me close this window here, and now if we just go back to the page we previously were, we can actually check what we can go here to .NET Preview 5 to release notes to see what version of Visual Studio .NET 9 actually requires. If we scroll a bit below, we will see that .NET 9 is compatible with Visual Studio 17.11 latest preview, and if I click on it, can basically download the latest version here in this part by just going to Community 22 to download the free version. And the downloads start right here, but I actually have the Visual Studio installed and I could have just updated it on my application, but let's see how it works right here. If I click on it, I should receive the option to actually just upgrade. Continue. Now the Visual Studio installer is opened and it gives us the option to update to the latest version. I'm just going to click on update and the download starts. Give it a bit of time. Now after a while, the Visual Studio's latest version is already installed, as you can see here. So we have the latest version of .NET the latest version of Visual Studio, and we are ready to go. Now, one last thing you want to do if you are using a preview version like myself is actually gonna need to go to the settings to Visual Studio to allow these previews. So let me open up Visual Studio, click on continue without code, so I don't need to open a specific project, go to tools, go to manage preview features, and a bit below we should see an option here. We should click on this option here, use previews of the .NET SDK. This enables the ability, as we can see here, to consume preview SDKs by default. If I click on it, click on OK. If we restart the Visual Studio, then we should be able to work with the preview version of .NET 9. You need to know the contents of each file in your project when building anything in programming. For this reason, I'm going to explain to you concisely the role of all files you have when you create an MVC web application project in ASP.NET Core. To create our first application, we can just open Visual Studio and click on Create a new project. Next, find an MVC template for a web application and make sure that C# is the language for this template, not F#, for example. In the page that loads, give a name to your app, like My App. You can change the location where you want your project to be stored if you want as well. Click on Next, and here I will select the .NET version to be .NET 9, this preview version, but the final release of .NET 9 may be available by the time you watch this tutorial. Let's leave all the other settings as they are for now and just click on Create. Here we have our application. When you create a new ASP.NET Core MVC project, several key files and folders are automatically generated. Let's go through them one by one. First, we have the program.cs file. This is the entry point for the application. This first line initializes a new instance of the Web Application Builder class, which sets up the configuration, services, and the web server. Next, we add services to the dependency injection container. Here we are adding MVC services to the container with support for both controllers and views. This allows our application to handle incoming HTTP requests and render HTML views. Then we build the application. This line compiles the app, creating a web application instance, which you can then configure and run. Now we configure the HTTP request pipeline, which determines how requests are processed by the app. If the app is not in the development environment, we set up an exception handler to redirect users to the home/error page when an unhandled exception occurs. Additionally, we enable HTTP strict transport security to enforce secure HTTPS connections. We continue configuring the pipeline with this app.use HTTPS redirection, which ensures that HTTP requests are redirected to HTTPS, and app.useRouting enables routing, which allows the app to match incoming requests to the appropriate endpoint. Next, we have the app.useAuthorization, which is responsible for authorizing users to access secured resources. We map then static assets. This line enables serving static files such as images, CSS, and JavaScript from the www.root folder. Then we configure the default route for the MVC application here. This sets up the default route pattern, which maps to the home controller and its index action method by default. The ID parameter is optional. So this is the default route that will be redirected to when we start our application. Every URL is actually assumed to have this pattern. The first part is the controller, then a method of that controller, which is actually called an action in ASP.NET Core, and the ID that is optional. Let's say a request is made to a URL called /items/overview. Our application will try to call an action called overview inside an items controller. And now let's go to the last line. Finally, we run the application. This line starts the web application and begins listening for HTTP requests. Now, let us now see what the other folders do as well. Just as a reminder, if you want to get the fundamentals right while learning C#, you should check out my ebook, which is on sale now. It will help you with whatever you're building in .NET and save you hours of research by providing all the C# insights you need in one place. This book will be a valuable resource for everything C# related, and you can find the link in the description if you want to check it out. Now back to the video. The controllers folder contains the controller classes. These handle incoming HTTP requests, process user input, and interact with the model to return the appropriate view. For example, we have the home controller here that is already created. The models folder then contains classes that represent the data of the application. Here we have a sample model, errorViewModel.cs, which is used for error handling. The views folder contains the eraser view files, or the .cshtml files, used to render HTML to the client. In this folder, you'll also find the view imports.cshtml, which contains directives that are imported into every view, such as tag helpers, and the underline view start.cshtml, which specifies common view configurations like the layout. Within the views folder, there's also a shared subfolder, which contains shared views like the layout, which is the layout page that is used as a default design for all pages, and this underline validation scripts partial.cshtml file, which contains client-side validation scripts. There's also a home folder, which contains views related to the home controller, such as the index view page and the privacy view page. The www.root folder is the root for the application's static files like CSS, JavaScript, images, and other assets. Inside, you'll find subfolders like CSS for style sheets and JavaScript for JavaScript files. For example, site.css and site.js are default files included for your custom styles and scripts. Next, we have the configuration files. The app settings.json file is the main configuration file for the application. It contains settings like connection strings and app-specific configurations, which we'll see later on. Let's take a look at the properties folder as well, where we have the launch settings.json file that contains settings related to how the application is launched during development. They can be modified to suit the specific requirements of the project or different development environments. And that's a quick overview of the main files and folders in an ASP.NET Core MVC web application project. I'm going to show you the basics of ASP.NET Core MVC using .NET 9. We will see how to work with the models, the controllers, and the views, and how they interact with each other, all in this short video. If you're new to MVC, this is the perfect starting point. I'm just going to go to the models folder and create a new model, or basically a new class for the models. I'll name it, let's say, item.cs. We'll see that a simple class will be created. Now, this class represents the data of our application. If we were to store this, which we'll do later on, in a database, this class that's stored in the models folder will represent a table in our database. And each property that this class will take will represent the different columns that the table will contain. So we can give to this class different properties. Let's say, let me just give it an ID property firstly, and I'll explain everything. So basically, we're setting an access modifier to public for this property so that it can be accessed outside the class. The ID, we name the property here, and it will be an integer. This is the type of data. And here we have a getter and a setter that allows this property to be accessed outside of our class. So this is an auto-implemented property. This is just some C# theory here. We can specify here different properties for our model. And we give each item an ID. We can give also each item a name. I'll set it to be public string. The name will have the data type of string. I'll name it name and the getter and setter as well. Now let's say we want to access this item in a specific URL pattern. Let's say that it would be /items/ let's say overview. So we'll create this application so that when a user makes a request to this URL, it will be redirected to a page that gives him the item. For this reason, what we're going to need is we're going to need a controller named items and also an action in that controller named overview. Let me just go to the controllers folder and add a new controller. I select an empty template here, click on add. I'll name the controller to be items controller. And we'll see a simple class here, an items controller, the items controller class, which inherits from a base controller class. Basically, every controller will inherit this base controller class because it inherits multiple methods, but you do not need to worry about this for now. We can see, as we talked before, each method in a controller is called action in ASP.NET Core MVC. And here we see this index method or this index action here. This is a public method. It returns an iAction result and it's named index. I'm gonna clarify to you in the next section what iAction result means in more detail, but basically this just allows our method to return different types of things. In this case, we are returning a view, which is actually included in this iAction result return type, but as I said, we'll talk about the action parameters and action result types in the next section. For now, what we'll do is that I'm gonna actually change the name of this action to be overview, since we wanted the user to be redirected to this specific route. And I'm going to take an instance. I'm going to create an instance of the model that we just created here inside this action. Taking a variable, naming it item equals to new item. And I'm going to need to import the model on top of the controller so that the controller knows the model basically that we created before. So I'm going to need to use this using directive, the name of the application, .models here. And as you can see, this item keyword is now in green because the page recognizes what it means. And let me just create one item here. It's not necessary for me to give an ID to the model because the program will give it itself. So I'm just going to specify for the item the name property. And let's give a name to a random item, let's say keyboard. And that's it. So I have created an item here and I'm going to pass it actually to the view so that we can be able to render this item that I created here inside the view that we'll basically need to create. What this action here does is that it creates the item, it renders the view, but we're going to need to create the view because we don't have a view named overview yet. We can just go to the views folder. We're going to need to actually create a folder to store all of the views inside the items controller. For this reason, I'm going to name it items. And inside this items folder, we can store views for each action in this controller. And for our case, I'm creating an empty view and I'm naming it according to the name of the action, which was overview. And here we have our overview CS.html page. Here we can write the plain HTML code that will be rendered to the user, but we can also embed here C# code, which we'll see in a bit, what we want to store in this page. I'm actually writing a HTML paragraph here, and I'm going to display to the user, this is the name of the item. And for me to actually access this item model that we created inside our controller here, that we put as a parameter in the view, I'm going to need to import the specific model on top of our view page. I'll do it by just writing this @ model and then the exact address of the model that we created, which is the name of the application, that models, that the name of the model, item. And now I can access the item that we gave into the view by just writing this @ sign. The @ sign we'll use a lot. This is how we basically write C# code inside our view pages. And for me to access the model, I need this model keyword and @model. And here I can access the ID or the name of our model. I'm going to access the name here in this case. And now if we run the project, let's see what we have written now. Now, this is our home controller, the index page, the default route of our application. So this is what we'll see here. But if we go to /items/overview, we will be redirected to the items controller, to the overview action, which will actually render our overview view page. Let me just hit enter, and we should see here, this is the name of the item, and then the name of the item, which we specified by using this C# code in our view page. So this is just the basics. It may seem a bit complex right now, but you have worked with models, controllers, and views all in this short video. I'm going to explain to you what iActionResult is in ASP.NET Core, why we use it, and I'm going to walk you through everything you need to know. In the previous section, we saw inside our controller that the actions return this iActionResult. But what is the iActionResult? iActionResult is an interface that basically defines a contract for all the different kinds of results that an action can return. Inside of an action, we can return to the user different results, we can return a page, we can redirect the user somewhere, we can return a JSON, just a simple message, and so on. All of these different action results derive from the iActionResult interface. In some cases, we may have a condition inside our action which would return different information to the user depending on specific requirements. And in this case, for us to include each of these different return types in the return type of the action, we specify here iActionResult instead of just specifying, let's say, view result or content result, so that it includes everything that the action can return. Let me just remove this and show you what we could use if we didn't use the iActionResult. If we would want to just return a view, let's say we can just return here a view result and then return the view here. Actually, the view that we are returning here is just a helper method that is inherited from the controller class, and it's just a shortage of this view result. The long way of writing it would be return new view result. But as I said, this is a helper method that allows us to write it in a more flexible and short way, and this is the way you will mostly see it in the code or from the documentation. So we could return different kinds. We could also return other kinds of information inside a action. We could return content result. Here I can just write return content. Content is as well a helper method. Here I can just write a message to the user like hello there. We can return just JSON result, a redirection result, and so on. But every of these different result types inherits from the iActionResult. And as I said, that's why we basically just write on top of as a return type of every action iActionResult, so everything is included in it. I'm going to explain to you what action parameters are in ASP.NET Core and the different kinds of them. I'm going to walk you through some examples as well so that you'll learn how they work. So let's get started. Action parameters are a way for our actions to receive input data. This input data can come from different sources such as URL segments, query strings, form submissions, or even a combination of some of these. Let's just start to see how the URL segment parameters work. In our items controller, I'm just going to create a new action. So public iActionResult. I'm actually going to name it edit. And here in this action, I'm going to receive an int ID parameter from the URL. And in this case, the parameter is passed to the action directly from the URL depending on the route configurations of our application. If you remember in program.cs, the default route pattern here is specified and it actually allows us to receive an ID parameter. Okay, so let's go back to the controller. And I'm just going to return on the screen some content. I'm going to write here return content, and I'm just going to return basically a message on the screen. So I will return the ID. Then I'm going to pass here the value that we get of the parameter that we get from the URL. Let me just run our project. And if I go to this specific route to items, the name of the controller, slash edit, slash, let's say 231, whatever number you want, we'll see that the parameter is passed to the action from the URL directly, and then we have displayed this parameter on the screen. So we can see here that the ID is equal to 2. Now let's just see how the query string parameters work. So query string parameters are this part in the URL that comes after the question mark, and they are usually used to filter or to sort. This method is usually used to filter or to sort data actually. Let's just see here how it works. So after the edit part, we'll input here question mark and give the ID the value of, let's say, 4. Click on enter and we can see on the screen that the ID has the value of 4. So the parameter is passed from the query string to our action, and we see here the value of the ID on the screen. Now, another way would also be, as I told you before, to take data from form submissions, but do not have the necessary knowledge yet. So I'm just not going to take an example for it. And one last thing I wanted to mention is that if we would actually change the name of the parameter we take from our action here, let's say change it to item ID, we would be able to still get the data from the query string, but we would not be able to take this from the URL segment, just because in the program.cs file here in the pattern of our route, we have specified that we can take from the URL can take an ID parameter and not an items ID parameter, so to say. So if I just go back here, run the project, let's say if I go to the route here, items slash edit, and I write this query string items item ID equals to 5, we should still see the value of the ID printed in the screen. But if I would do it using the URL segment, like edit slash 7, we would see that the value of the ID would default to 0, just because we are not taking the value from the URL in this case. Razor is a markup syntax used in ASP.NET Core to embed C# code into HTML. It's designed to be clean and concise, making your code easier to read and maintain. You'll commonly see Razor syntax in views, which are responsible for rendering the UI. Razor syntax is denoted by the @ symbol. Now let's look at some common uses. First, let's start with basic variable embedding. Suppose we have a variable that we want to display in our view. In this example, we declare a variable message inside this code block that we can write inside our view pages and use the @message syntax to embed its value inside a paragraph tag. Razor also supports embedding more complex expressions and C# code blocks. For instance, let's loop through a list of items and display each one of them. Here we use the @forEach loop to iterate over a list of items and output each item within a list tag. Notice how we seamlessly switch between C# and HTML. Razor syntax also includes conditional statements, which are useful for rendering different content based on certain conditions. Let's see an example with an if-else statement. Depending on the value of the isLoggedIn variable, Razor will render either welcome back or please log in. This makes our views dynamic and responsive to the application's state. Now let's talk about the Razor directives. Directives are special instructions for the Razor engine, and they're prefixed with the @symbol. Some common directives include @page, @modal, and @using. For example, the @modal directive specifies the type of modal data the view expects. This is crucial for strongly typed views. In this example, the @modal directive is used to indicate that this view expects a myViewModal object. We can then access the model's properties using @modal. Lastly, Razor has a feature called tag helpers, which allows us to dynamically add behaviors and attributes to HTML elements. Tag helpers make our Razor views cleaner and more maintainable. Here's a simple example using the ASP4 tag helper. The ASP4 tag helper binds the input field to the name property of the model. This ensures that the correct value is posted back to the server when the form is submitted. So what is Entity Framework Core? Entity Framework Core is a toolset for .NET developers that simplifies database access by allowing us to work with databases using .NET objects. It eliminates the need to write complex SQL queries by providing a way to query and manipulate data using C# code. Entity Framework Core supports various database operations like creating, reading, updating, and deleting data, making it easier to manage database interactions in an object-oriented manner. There are two main approaches to using Entity Framework Core: the code-first approach and the database-first approach. In this video, we will learn how the code-first approach works. The code-first approach in Entity Framework Core allows us to define the database schema using C# classes and then generate the database from these classes. The database-first approach works the other way around. The code-first approach is ideal when starting a new project without an existing database, as it provides full control over the data model through code. Okay, so we're going to start with the code-first approach, and we're just inside our MVC web app template here in Visual Studio. The first thing we're going to need to do is go to the dependencies here, click with the right of the mouse, and select Manage NuGet Packages. We're going to need to install the needed NuGet packages in order to implement Entity Framework Core inside our project. So the first package we need here is Entity Framework Core. The first one you see here, click on Install. Click on I accept. Next, we need the Microsoft Entity Framework Core tools. Click on Install as well. And then the Microsoft.Entity Framework Core.SQL Server, since we are connecting our project with a SQL Server database with SQL Server Management Studio, actually. Click on it and install. So all of these packages that we're installing right now have necessary tools and commands needed for us to basically map our C# classes and models and generate a database and connect it basically with the SQL Server database. Okay, now that we have all of our 3 packages installed, let's just check the models that we have in this project. So here I have only like a simple item model with an ID property and a name property, and we will just store this model inside our database. What we're going to need other than our model, we're going to need a context class, which as a practice is stored inside the data folder. And I'm just going to explain to you what the context class is needed for, but let's just create the data folder firstly. Just add a folder called data, and inside the data folder we're gonna add a class I'll name it my app context or something with context in it. Click on add. Now here we have our context class. We are going to need that our class inherits from the entity framework course DB context class. And let me see what we need to inherit here. We need actually to inherit entity framework core on top of the page, I would suggest. Using entity framework core on top of the page, and this class basically contains many properties and methods in order for the context to do its work. So the context is this class, like the main bridge that connects our project with the database. Here we store every instance of the models we have in our project, and with the context, with the method that the context provides, it's possible to basically query data from the database, filter them, get the data, or modify them. What we're going to need after inheriting the dbContext class is we need a constructor inside our context class, and this will just contain a few generic parameters to enable the needed configurations for our context. So these are the parameters that our constructor needs to have. And what we also need to write here is, as I told you, we need inside the context, we store an instance for each model that we have in our project. In this case, we have this item model, and we need a dbSet instance, which is this entity framework class, and this will be for our item model. We give it a name like items, and we give it this getter and setter. So this is written just like a property and enables us to access this model from the database, and basically what we have in our project to store it in the database. We need to import the models folder on top of the page, my app.models, and this is it for the context. The next step we need to take is to create a database instance in our SQL Server Management Studio that we're gonna use as the database for our project. We can just go to the view menu here and click on Server Explorer. Here we have all of the basically a lot of database instances I had created before. We just need to go here to data connections, click with the right of the mouse and click on create new SQL Server database. Here we need to write the server name, and basically if you open up the Microsoft SQL Server Management Studio, you will see the server name on top of the page. We can just click the name of it here, connect the SQL Server Management Studio to our server, and go back to the project. Input the name here. We'll use the Windows authentication to log on to the server. The encryption will set to false. You click on Trust Certificate here. We're just selecting here the authentication. This is a default one. We're selecting that we do not need to use a password to connect to our database. Basically here, just some options, just some configurations. Don't think too much about it. And give the database a name, like my app database. Click on OK, and after the database will be generated, we should see in this window right here the name of the connection string. The connection string is the address of the physical database. So basically this tells us where the database is located. We should copy this, and the connection string we need to input it in our app settings.json file so that we then can connect our project to this physical database. Here we need to write connection strings, and we need to give a name to the connection string. I usually name it like default connection string, it doesn't matter. Here we input what we took from we input the name of the connection string, just right here with the name of the server, the name of the database, as you can see here, and we put the encryption to false, and some other configurations. The last step now to connect our project to the database would just be to go to program.cs and add a service in the services containers. Basically, this will connect our database with our project and with our context. So I'll just add the service here, builder services that add context. The name of our context was my app context. Here inside we'll just input a few options. Let me input this in a new line. Options does use SQL Server. And inside here we need to access that connection string to get the location of our database, builder.configuration.get connection string, and we need to input here the name of our connection string. Close the parenthesis here. So basically we are writing a service to connect our context basically with our database here. Just let me remove this dot here. We need to import entity framework on top. We need to add the migrations to our database. A migration is basically just a class that will be created that is the code, the representation of how our database will look like, with all of our configurations for our models and the context that we have already written here. So to do that, we're just going to need to go to Tools, Package Manager Console here, and just write a command, add -migration, and just give a name to the migration. Hit on enter. So build succeeded, and we should see this migration class here on the screen. A migrations folder will be basically created. The migrations track every change we do to the database schema, and each time we change the models or the context, we need to add a new migration to the database. You can see here that the table will be created on our database with a columns, an ID column with its specifications, and a name column here. The primary key is by default the ID property, as we can see here. And the last thing we need to do is to basically write the command here, update database, and this migration will be added to our database. Right now, a table for our items should be generated already in our database. If you go to SQL Server Management Studio, to databases, let me find the right database of our project, which were my app database. You can click on tables. We have a table for the migrations here, entity framework or migrations history, which basically tracks all the changes to the database schema that we make. And right below we see the items table, if we click on edit top 200 rows, we should see basically an empty table, but the table with an ID and a name. We can click on design here to see our columns. So this is how Entity Framework Core's code-first approach works. In this video, we will learn how the database-first approach works. The database-first approach in Entity Framework Core involves generating C# classes and a DB context from an existing database schema. This method is suitable when working with a legacy database or when the database design is managed outside